Hi guys, good morning one and all. This is Hanuman Naik and welcome to our channel Smart Study. I know that you are eagerly waiting for your answers. Yes, now the time is came to check your answers. Now check your answers, guys. So the question number one is what is the unit for measuring the amplitude of the sound? Amplitude of the sound we will measure with the help of in the what instrument in decibels. Amplitude will becomes in the decibels. The units of the sound is what decibel, guys, and coulomb for the what charges, and the cycle is a different and hum is a different. So this is coulomb for what charge, electric charge. Then the next question, the nanometer is equal to nanometer 10 to the power of minus 6 minus 9 minus 12. Which one is the your answer? Minus 9. The light year is a measure of. So light means what? Don't think is a what velocity or speed or time. The answer for the third question is a distance. Okay, what do you know that what is the meaning of the light year? To complete one revolution to the earth, how much time will it take? That is comes as light year. That is the answer. Light year is measured of what distance. Then kilometer is equal to, see guys, here kilometer and miles, the relation between the miles and the kilometer, you have to check that. 1 mile is equal to 1.6 kilometers, guys. 1 mile is equal to 1.6 kilometers. So from that, 1 kilometer is equal to how many miles? 1 kilometer is equal to 1 by 1.6 miles, guys. If you do the calculation, you will get 0.62 miles. So see the conversion, how I did the conversion. 1 mile is equal to 1.6 kilometers, and 1 kilometer is equal to 1 by 1.6 miles. If you do this simplification, 1 by 1.6, you will get 0.62 miles. Now in bar is a unit of pressure. You already knows that bar is the pressure of unit of what? Pressure. The next, I will zoom it. Wait. Next is nautical mile. Nautical mile is used to measure what? Not a road miles, not a astronomy. Nautical miles to use the navigation purpose. In a navigation, do you know the what is the navigation? Is a Google map is there na? Is working off with the help of navigation only. Nautical miles. And the next, how many dynes are there in 1 gram? You know that what is the z value, guys? G, small g, gravitational force, acceleration due to gravity value is constant how much? 9.81. Okay, this is the dynes. How many dynes are there in 1 gram? Means into 100, that is equal to 981. Just remember this value, 981. Same value here, 981. That is your answer. And now tell me that our favorite joule. Joule is a unit of what? Heat, not temperature, not power, watts. What is the units of power? Watts. Temperature, Kelvin. Heat, what is the heat's units, guys? Do you know that? Yes, I will tell you that when this topic will come. Then next is energy. Only the left out is what? Energy. Energy units are what? Joules only. How many eggs are there in 1 joule? How many? 10 to the power of 7. How many eggs are there in the joule? 10 to the power of 7, guys. Now next, 10th one. Electric current is measured in what? Amperes. With the help of ammeter, they will measure in amperes. Horsepower. 1 horsepower is equal to 746 watts. How many? 746 watts, guys. And the next thing, yeah, just wait it. Yes, where is that paper? Photo papers is there? Physics papers. Yeah, okay. Now see the next question. A goalkeeper in a game, a goalkeeper in A game of football pulls his hands backwards after holding the ball shot at the goal. This enables the goalkeeper to exert the large force on the ball, increase the force extended by the ball and hands, increase the rate of change of momentum, decrease the rate of change of momentum. Which one is your answer, guys? Tell me quick. Decrease the rate of change of momentum. Yes or no? Yes. Due to that reason only we did the class of 2 days of class on momentum only, change of momentum and impulse. So here to decrease the rate of change of momentum, we will use that the goalkeeper, those who are in goal in the football games or any cricket games, if the ball, when the batsman or any hitter will hit the ball, at that time the ball will comes a very high speed and with a very large huge force. To reduce the force on the hand, to avoid that force, we have to pull your hand and your side, that is back side. Why? Because to reduce that change of the momentum, to reduce the change of the momentum. The next question, yeah, just wait. The next question, an object. Now this is an important question, guys. An object of mass 2 kg is sliding with the contact of 4 meters per second on a frictionless horizontal table. Frictionless horizontal table. Then the force required to keep the object moving with the same velocity. Guys, remember here the word is the word frictionless horizontal table. Without, if there is no friction, what happens? Your force will be 0, guys. They are giving the numerical problem, but if you use that your common sense on that, if you listened my classes with carefully, then your answers you will can do the whatever I gave the paper 35 questions without pen and paper. Without pen and paper. Here there is some calculation. You may think that while seeing the question it has some calculation is required, but there is a word frictionless. If there is no friction, what happens? Can you able to stand under earth? Can you walk? No. These all things are not possible. At that time your force is 0. Remember that your force is how much? 0, guys. Important problem. Next question. Question number 14. Newton's third law of motion explains that Newton's third law of motion explains the two forces, namely action and reaction, coming into the action when the two bodies are in the contact with each other. These two forces. Now see how they are giving the diagram. Here there are the two bodies, body A and body B, and here there is a one hinged force is there. He joined with here, and these two bodies are joined by with the help of some hinged joints. That is S type of joints, and here one person is that is what pulling. He applied the external force and pulling. Then what happens, guys? It will, the length of the here how much is there, that will be somewhat increase or decrease, depends upon his force, how much he applied on from the external side, depends upon this force. There is a somewhat changes will come in here or in bodies, right? So here how many bodies are applied? Two bodies and different sides are not. Yes. Now see that always act as same body. Here only one body is there. No, always acts on different bodies in opposite direction. Yes or no? When he pulling it like this, actually the bodies will have to stay at the same place. Okay, actually if you are not applied on bodies, everybody feels that, like a human being, like a you, yeah, if there is no external pressure from the teachers or parents, if there is no pressure to write the exam, then what is your feeling, guys? You have to stay in home to play and chit chat with your friends. Yes or no? Means that if you are not apply any external force on the body there is no change in between the bodies. Now here is what, if you are applying always different bodies in the opposite direction, means if you are not applied the force on that, the bodies always feels that we have to stay at a constant place only. Okay, if you applied more force other than the individual body, then it will be become what? Changes. Now always same action body? No, this is not in same body. Always different bodies, maybe is correct. See that. You have to read all the options. Have same magnitude and direction? No, not same magnitude and same direction. Okay. Magnitude means what? It's their own individual energy. Energy can't be. My energy and your energy is equal? No. I can hit you, you can hit me. Right? When these two persons are hitting, the fighting, the bodies, the energy of the two bodies is not same, not a same magnitude and same direction. If both are in same direction, it is not called a fight. Right? So this is wrong. First one is wrong and third one is wrong. Acts on either body at normal and each. Not normal. If normal, that is what? Discussion, not a fight. So there is no force applied on that. So you can tell, right, your option B is correct without any doubts. Understood, guys? Now see that 15th problem. Now see the 15th problem. The problem in rockets. Yes. While seeing in this picture, what you decided? What do you? Inertia, momentum, conservation of momentum. Your answer is conservation of momentum. Rockets are working in that principle. In a rocket, a large volume of gases produced by the combustion of fuel is allowed to escape through its tail nozzle in the downwards. Yes, this is the force is coming in downward direction and it is going in upward direction. Action, reaction. Without this reaction, action, it will goes upward. That is action. Downward direction with the tremendous speed and makes the rocket to move upwards. Yes, with the help of this speed only, this conservation of energy only, the rocket is going. The fuel is burning, guys. Here fuel is burning. When the fuel is burned, the next force is what? There is a action should be the possible. That action is designed in such a way that to move in upside. Okay. So here you see the options. You understood the question. I hope you understood. Now see, you decide the options. Which principle is followed in this takeoff the rockets? Takeoff the rockets with moment of inertia? No. Conservation of momentum? Yes. That's the answer. Newton's third law is not, guys. Here action, there is a reaction. Don't see that. If here what is the word action and reaction is the word is there, na? So in the previous question also is there action, reaction. But here also there is a action, reaction. But don't think that this comes under category of Newton's third law, not a third law. When here with the help of this conserved energy, it is in moving upward direction. So conservation of momentum, guys. Okay. Let's see. So what is the question number this? 15th is completed. Now coming to the 16th. Newton's law of gravitation. No, nothing. Yes, sir. This question is an important question. I like this question. See, guys. A water tank filled up to 2/3 of its height is moving with a uniform speed. On sudden application on the brake of the brake, the water will be and tank would be. See, here understood that. Before going to explain this, I will tell you one thing, one condition of this. If you are in bus, the bus is or you are in train, the train is moving condition. When you are in a train, the train is moving condition. Your direction, your body feels that you have to travel along with the bus or along with the train. Only now, if he sudden brakes, then what happens? If he sudden brakes, you falls down the bar. Can you suddenly, if he suddenly brakes, can you move backward side direction or front direction, forward direction? When it is in moving condition, if you are in that in bus, you have to move forward direction only. If there is a body in rest position, if he starts suddenly, at that time he will be bent backside, backward direction. So I explained in already in the classroom, last class teaching, last class video. And now this. Now see that there is a one water tank. In the water tank, so suppose the water tanker is a one body like a train. Assume this is not a water tank filled up to the 2/3 and its height moving with a uniform speed. So there is a water tank in the train. There is a water tank in the train. The train is moving condition. Water tank will fill somewhat up to how much? 2/3 of height. The vehicle is moving condition. If he suddenly brakes, then what happens, guys? It is in moving condition. If he suddenly brakes, water will fall in the move to forward direction or backward direction. If instead of you, they use that what is what? Water. If any body, if they are in somewhere, the body along with the moving condition, then if he suddenly brakes, if the body in the moving, it will be false, it will be goes towards the body direction, that is forward. If the body in rest position, it is a backward direction. Now tell me that what is the option? Move backward? No, because of it is in moving condition, not backward. Move forward? Absolutely correct. It is to come to the rest? No. Is unaffected? No. So your option is what? B, guys. Now see the next question. Yes, now see that. Here see, guys, this is the one of the important question. How to solve this problem is important. The solution of this question, how the way of approach is important, guys. Velocity versus a time graph of the ball is a 50 grams rolling on a concrete floor is showing in the figure like this. Is a concrete floor, like the ball is flowing below. What will be that frictional force? So when the frictional force is acts, that is mass by g only. Mass by g only, guys. Now for this question, without pen and paper you can solve also. So mass is frictional force is always acts in downwards, that is mg. Here see that the forces are newtons. Here 50 grams, and it will be become what? Newton. Or here see that option 0.5, 55, 0.05. All are in 5s only. So if you assume z value is 10, then what happens? 50 by 10. 50 by 10, how much, guys? 50 by 10, it will be become 5 only. But here is a what? 0. Here 5 is the option is correct, or 0.5 is the option is correct. Which one is the option is correct? Now tell me yourself. Pause the video and tell me that my option is the correct option. This question I am giving to you only. So here answer is not a 5. I am giving the answer. Answer is 0.5. How? Here see that. Here the units conversion only is the left out. One is the what? Grams. And here g values are what? G value units are meter per second square. Okay. These are in meters. SI units, G in the CGS units. If you convert these units, then after that if you did the work, then you will get this 0.5. Now yours job is about how these grams to kgs you have to convert. After conversion of that, how to solve that. Force is equal to, how to get the Newton? Force m into g, m into a. Mass is by 0. How much, guys? 0.05 into, and g value is how much? 10. A value is 10. Then it will be become 0.5. I only told. Okay. Now completed. Got it? How the Newton is came? 0.5 Newton. Now see the next question. And this also the important question. See, for this question also there is no need. When the physics question is somewhat lengthy, don't think that the question is tough. If the increase of length of the question, then you have to decide in your mind is what? Answer is very easy for this question. See that question. The seat belts are provided in case of cars that if the car stops suddenly, what happens? For that what? If cars are, again previous, like a previous question only this also. The seat belts are provided for what? Emergency purpose. The person sitting on the front seats are not thrown forward violently and saved from the getting injured. Yes, we know that. Can you guess the law due to which a person fall in forward direction on the sudden stopping the car? Which law, guys? Newton first law, second law, third law. These all are either seat belt or forward direction, backward direction. These forward or backward. Each are examples for law 1. Which law? First law. These all are the examples of Newton's first law. See the options. Newton first law, second law, third law, law of gravitation. Which one is the option? First only the is the option, right? Now see that next question. When a balloon held between the hands is pressed, its shape changes. It happens due to what? Balanced or unbalanced? Which one is the option? Balanced forces acts on the body balloon. That's the answer. Now see the next question. Question number 23. Which of the following situation involves Newton's second law of motion? See that question. For read all the questions, what is the Newton's second law? At that time you have to recall the what is the Newton's second law. F is equal to ma. And see that options. A force can stop a lighter vehicle as well as a heavier vehicle which are moving. No. And see a force exerted by a lighter vehicle and collision. No. A force accelerates lighter vehicle more easily than the heavier vehicle which are moving. Yes, it's the correct. No need to read one more question, one more option. Now see the next question. Next question is the speed of the car weighing 15 kgs increased from 36 km per hour to 72 km per hour uniformly. Increasing speed is in. What will be changes in the momentum? Yes, in the previous class only when we discussed the problem about the momentum, we wrote that mass into change in velocity. Mass into is change in velocity. I told in the previous lecture delta V. Yes, mass is how much? This is mass. Mass units are kgs. This is a 1500. And delta V change in. Delta V means V2 minus V1. V2 means V1. 72 minus 36. How much, guys? 36. Now, if you multiply 15 into 36, how much you will get? 54,000 kg meter per second. Here kg and here is meter per second. But okay, so but you have to see, be careful with your options in what we call the units. Here is a kgs and here is a what? Kilometer per hour. So when the kgs and kilometers per hour is there, you have to convert kilometer to kilometer per hour to meter per second. How to convert? You have to multiply 5 by 18. If you multiply 5 by 18, then you will become meter per second. Then your answer is 1500. This 1500 into 36 into 5 by 18. So finally your answer will be give the 15,000 kg meter per second. Kg meter per second is the answer. See this conversion, kilometer per hour if there, then you have to convert in meter per second. You have to multiply 5 by 18. The next, a passenger is moving in a train, tosses a coin which falls behind him. Okay, and observing this statement, what can you say about the motion of the train? It's accelerated or not? Yes, it is accelerated. Yes or no? Yes. The option is A. The Newton's first law. Newton's first law of motion says that a moving body should continue to move forever. Yes, unless some external force acts on it. Excellent. That's only we are telling always. But a moving cycle comes into the rest after some time if we stop the paddling it. Can you choose the correct reason for the stopping a cycle? Air resistance, gravitational force, no. Friction of road, excellent. So your option is 1 and 3. That is there in where? Option B. Now see that next question. See guys, this question also important. A man wearing a bulletproof vest stands under rocker skates, and the total mass is 80 kgs. Mass m is equal to kg. A bullet mass is 20 grams. Is fired at 400 meter per second. It is stopped by the vest and falls in the ground. What is then the velocity of the man? Velocity of the man. So I will tell you that this type of questions in the next previous class is these are the questions are important for the competitive field. For this, the answer is 0.1 meter per second. Now see that. Next. The unit of measuring the momentum of a moving body. Momentum units kg meter per second. Yes or no? Yes. The inertia of moving object is depends upon mass of the object only. And where is the moving object is depends mass of the object only. So that is option. Which one is option? Only one. That is B. Now, see, this question is important. The question is, a block of mass is m moved over a distance d and applied force F and opposite to the block's displacement. How much work is done on the block by the force F? How much is these two are opposite works, guys. Work done is equal to F into d actually, or F into S. That is, if you apply the opposite means negative F into d. So your answer is minus F into d. Opposite means negative force. The next. Next part. Yes, 28. The question number 28. A construction worker, right, holds a heavy toolbox. How much work is done by the worker? See guys, in the previous lecture only I told that if you hold the body, the work is not completed. If you want to complete the work, if you have to lift the body and you have to travel some distance. If you are not traveled that, if you are not travels some distance, then your work is completed. No, he is only lifted the body object, but he not travels. There is no distance he is travel. So when he no distance is travel, his work is what? Zero only. Did he done any work? No. Okay. Yeah, see, when you are using that your brain, you will get that good knowledge in the physics, guys. Use some common sense. And these questions are important questions. Now see that. A container with a mass of 5 kg is lifted to height of 8 meters. How much work is done in the gravitational force? If gravitational force means what? If there is a container, he lifted some height is 8. So if the body is going in upside, your G value become what? Minus 10. If you assume minus 10. Yes, and G is minus 10. So means you are getting answer in negative. So if there is a body is work, how much work is done? If body is moving upwards, here if you think that body is here, this body is maintained somewhat distance from the earth. In this particular case, which force is applied? Which energy? Potential energy, that is m into g into h. M into g into h, potential energy. Mass is 5 kgs, g is value is 10 and height is 8. Yeah, complete answer is what? Negative, because of it is in upward direction. G value become minus g, remember this. So if you multiply all this, you will get minus 400 joules. If there is a in downward direction, G value is plus. So at that condition, plus 400 answer. So for the next question, plus 400. And next day, if the returned back to the ground level, there is a no work, that is 0. These three questions are interlinked combined questions. See the next question. Yes, and one of the important question. A truck driver slams off the brakes of the moving truck with a constant velocity v, as a result of which action of the truck stops after traveling distance d. If the driver had been traveling with twice the velocity, then what happens? So here you have to find the kinetic energy, guys. Here they are asking kinetic energy, that is half into mv square. If there is a this equal to d, if you think d, if the velocity is doubles, then what happens? Half mv become 2v whole square, right? So it has 4 into this 2 square is 4 and 1 by 2 mv square. So how much is changing? 4 times is greater, is 4 times its value is increased. Now see the next question. Yes, last 3 questions. See that what happens, the total energy of moving object is fall and the applied force are the conserved. What happens, guys? It's increasing or decreasing at what happens now? Tell me that. If total, what happens, total energy of a moving object, if all the applied forces are conserved, it remains constant, guys. It remains what? Constant. Next, a machine does 2500 joule in 1 minute, then power. Okay, so power is equal to what? Work done by time. Work done by time. Now see that if you are confusing anything, now here see that this is joule, so work done units are joule. Joule per time you want, joule per time, that will get power will use that. Now see that here time in what? Minutes. Don't use that in minutes, use in seconds. Here joule per second in 1 second, this value should be in seconds, guys. So this 25,000 by 60, 1 minute means how much? 60. If you cancel it, 6 ones are 6 fours are 24 and 6 fours are 24 become 1, then it will be how much? 41 point something na? Here how much is 25 1, so is approximately 42. Your answer is 42 watts, right? Now see the last question. Here see that next question. A car travels with a constant speed of 15 meter per second. The car engine produces, this is the force. Newton is always for what? Newton is a unit of force, so you have to write 4000 newtons. Force value they gave that 4000 newton, and speed, that is velocity, they gave that 15 meter per second. 15, this is meter per second, and they are asking that how much power is produced. So power value they are watts. Because of, if you are getting confusion, what they are asking, power developed means, if you are not getting this word, then go through the options. All option units are what? Watts only. What is a unit for what? Power. So you have to find that power only, guys. So in this case, what to do that? When they are giving the power and speed or velocity, instead of power, joule per second. Joule per second. Always you are doing that what? Work done by time only, work done by time. Now in this particular question, see that in this particular question, this joule means what, guys? This joule is nothing but Newton meter by second or not? Yes or no? This joule means Newton meter per second. Sorry, this Newton meter only. Joule means what? Newton meter only. Now see that, and when we are finding the power, in top side what we need? Newton meter. In denominator second we want. Here see that what is there? Force units are Newton, and next units is what? Speed units are meter per second. Yes. Now see that from this statement, can I write like this? Newton meter per second, Newton into meter by second. Can I write from this statement to this statement. Can I write like this? Yes. Means that what you understood from that, if you want to find the power when they gave the force and speed, just multiply these two. Just multiply these two and you will get power. The units are watts. So 15 into 4 how much? 60, and 3 zeros are 3 zeros, 60,000. So whatever you have completed the question, all questions you can solve with the help without pen and paper, guys. So up to that you understood, and if you are, again if you have any doubts about the questions and paper and answers, you can put in the comment box. Okay, and thank you. Bye bye. Sign off.